All systems green. Salutations, class, and welcome back. Speaking of class, we actually have a lesson tonight. Tonight we will be returning to GameMaker Studio 2, and we are going to learn about arrays and strings. Together, we actually have a very useful application of, as you know what I enjoy on this channel, fighting games. We can use them to make an input interpreter and, essentially, map out commands just like a fighting game would. And I'm going to show you just how we do that tonight. So, I've already messed with a couple of settings, and the text that we have should be a lot more readable. But to warm up, we might go ahead and look at a couple of things we were doing before. Now, those of you who might remember from the last time we were doing this, we wanted to do a dash and a double jump as potential things for us to mess with. In order for us to do that, we'll need to have a jumping variable to test when we are midair and how many jumps we've used, and we'll need to interpret how a dash input is made. And for that... Oh, my numlock is messing with my code here. In order to do that, we'll be messing around with arrays and strings and getting our fighting game input interpreter to do our dash input. A formal welcome to everyone. Kayla, Natsume, welcome. To start off with, we're going to want to make sure that we have a variable to track our double jump. But we do want some versatility in the future. Say, if we implement a character that has multiple air jumps. So we're going to want to start with a constant of, let's just give it a self-descriptive name of air jumps equals 1. We'll just use that for having essentially one air jump, since we don't really need to check if we're already jumping off the ground and decrementing our variable from there. From here, we will use jumps used, jumps underscore used to 0. And I'm going to show you what we're doing with that. So if we want to jump in the air, we're going to need to check if we have jumps used less than our maximum number of air jumps. And we'll also need to reset our number of available jumps every time we touch the ground. And I think you know exactly where we do that. So, going back to our code here for turning on or turning off our gravity, we have here the check for whenever we touch the ground, or touch grass for those of you that need it. This basically runs through our code every time, so it is actually where we'll put our check for if we're touching the ground and resetting our jumps. This right here, grounded equals true, vertical speed equals 0, is the code that executes whenever we touch the ground, if there's a wall 1 pixel directly below us. So we'll just append one extra line here and say jumps used equals 0. What this means is essentially every time we touch the ground, it thinks that we haven't used any extra air jumps. Now, that's just the only line we need to add to reset our number of double jumps every time we hit the ground. What we'll need to do to check for a jump here is go over to our jumping code that we had set up before. And now we get to mess a little bit with OR statements. So here we have grounded equals true, which is our check to see if we have jumped while touching the ground. We are going to append this, and I'm going to show you what an OR statement will do, which is pretty self-descriptive. Here, we'll go ahead and do an OR. How did this actually make sense? It's because I'm so good at doing the explaining thing, obviously. I am a professor, after all. Or I liken myself to you one. I hope you'll help me get my way into doing this regularly. So the way most languages handle it is they'll have 2 of these vertical bars as an OR statement. But Game Maker Studio is meant to be a lot more approachable to newbies, so we have or here, and we'll want to fit this all into a bracket together. Or grounded equals false, and air jumps. Wait, no. Jumps used less than air jumps. Welcome, James! We're just starting on our double jump code here. So, what this little bracket means altogether, if we press our jump key, this whole statement is contained, and now we have this whole bracket, which is an or statement, and it's got a couple of parentheses here, since we have a number of things grouped. So, what we're checking for is either our character is on the ground, or, and in this code block we check, are we in the air? And if the number of jumps we've used is less than our total number of air jumps. In fact, we actually don't need that entire and statement there, because either we are on the ground, or we'll just read the number of jumps we have remaining in the air. We don't necessarily need to signify that we are in the air for that check. Now, first off, we're going to go ahead and put another if statement inside of this one. If grounded equals true, and we'll only need an extra little set of curly braces like that. I'm going to show you a little trick. One thing that we've done so far is a number of the variables that we use that are relatively self-descripted, such as horizontal speed and vertical speed here. We have taken abbreviated names because we'll be typing them frequently. Same thing with if statements. In most coding languages, you can actually shorten the statements like this, and you don't even need the equals equals true. Boolean operators, which is to say true false if you're just testing a yes or no question, come up very, very often. So this right here, if grounded, is essentially the same as typing if grounded equals true. We'll do a little else statement here. So this is the bracket that will execute if we're in the air. VSP. You know what? As another trick, most platformers will have a different amount of jumping depending on if you're in the air or off the ground. Most games will actually give you a smaller jump in the air. So let's go ahead and do double jump speed equals -10 should do. Else, if we're in the air, vertical speed is equal to double jump speed, and then we're going to need to increase the number of jumps used. Jumps used. Now, there's a number of ways we can do this. Plus equals 1, as you've seen from the operators we've done before with the movement speed checks. The minus equals, plus equals, so on and so forth here. If you're only needing to increment a variable by 1, you don't need this. You can actually, similar enough, we have operators that we can shorten. Jumps used plus plus, which is essentially plus 1. You can do the same thing if you need to subtract, just do minus minus. It's altogether supposed to make your coding a lot quicker if you can essentially type out a lot of commonly used statements with fewer characters. So, running through here, actually, let's just go ahead and test it directly. We know our little block guy is a very helpful boy, so since he's so cool, you'll see he has put on a wonderful new pair of shades. And there we go. I'm going to go ahead and mash the jump key. And you'll see that I can't actually jump anymore after we've left the ground. There's one jump, and there's a second. Much smaller the second time around. He doesn't turn yet, instead he's walking backwards because he's a very cool guy. But we'll need to make sure he doesn't splat himself into a wall, so we'll go ahead and update that here in a moment. And there it is. With only a few lines of code, we have a double jump. We just need to add two more, essentially, one more variable and two more constants. Jump, and then when you jump in the air, you increment your variable for jumps used to increase by 1, and you'll reset it every time you hit the ground, just by implementing it in your code for whenever you touch the ground. Now, just to play around a little bit, let's go ahead and give him 5 air jumps. This is why you want to use constants, because you will have to tweak your game again and again and again. So you want to have these variables stored. Here we have air jumps, and even though we basically only use this about twice or so, yeah, we only have the constant here. That's the only place that we use that variable, or that constant. But for a number of these bits of code, in case you ever need to actually use this again or read this again, you'll have to have a constant name assigned so that you only need to change one line here and it will change everywhere else accordingly. There, our boy can do a lot more jumping now. Look at him go. And there's the double jump, done so quickly and so easily. Now, let's go ahead and make our little boy turn around. That's one more little thing we can do. So, let's think a bit. When do we want our little boy to turn around? Sure, we can have him go ahead and just change with your inputs, but that can create some very bizarre interactions. Instead, we're going to have him change his looking orientation whenever he's actually moving in either direction, because you can be pressing right and you'll start turning around as you hit left, but we don't want him to turn around immediately. There's a couple of interactions we can do with that, which might end up being a little weird. So, right here is our code, which handles horizontal and vertical movement. As well as our collisions, we have those condensed into one block here. Simple enough. We just need to put in x scale equal, wait, no. That's what it was. It was image x scale. You'll see that this is green. This is another internal variable handled by GameMaker Studio. And what it does is it is the horizontal scale of your character sprite. Since this game focuses so much on sprites, you're going to have a lot of ways to manipulate it and play with it. We have more complex ways to work with this function, but for now, we only need to mess with x scale. And here, image x scale equals sine HSP. So this is pretty straightforward. The sine here, as you see us using very frequently, just gives us if our horizontal speed variable here is positive or negative. But there's a little bit of a quirk that we might have here. So let's give it a test. He looks right when he's moving right, and he looks left when he's moving left. And there we go, the thing I was worried about turned out to not be true. It seems GameMaker does have a way to interpret if you are having a negative or positive 0. Welcome, ETG. Welcome back. We just implemented our multiple jump systems here, and we've just had our little rectangle boy have a way to tell which way he's facing. You can see that even if I start trying to move in the other direction, he'll only actually turn when his horizontal speed is positive or negative. And there we have it. Only 20 minutes in, we already have a proper way to check if we're facing or if we're jumping. So, now we get to the meat and bones of the lesson. Let's go ahead and set that back to 1 air jump. Hold on. We did create a facing variable here. We better use it. So, since we'll have to read facing in a lot of different places, we can't have image x scale just be essentially a replacement for a facing variable. Because what if we wanted to make our character wider or thinner for certain animations, or character states, or whatever? Instead, we'll go ahead and do facing equals sine, and then we'll append another line here, image x scale equals facing. And we'll go ahead and replace this line later, but for now, that's all that we have to do. Okay, now we're using facing, and essentially, our code should be the same. Indeed, look at the little boy go. Now, we get to learn about strings, and we get to learn about arrays. So, you know that we've worked with a lot of Boolean operators here. This is a Boolean, true or false. Basically, only a yes or no, and there's a couple of different ways that we mess with them, but so far, this is essentially the only Boolean we've had to mess with. Facing is also kind of a Boolean, as we should only have a facing left or a facing right, but it's interpreted a little bit differently as we use a -1 rather than a 0 for facing left. Essentially, false is equal to 0, and true is equal to 1. In most cases, a lot of other coding languages will be more strict and will only let you use true or false, rather than letting them be interchangeable with 0 and 1, like what GameMaker Studio does. This game is a lot more flexible with how it lets you handle things. So, there's a number of different data types, and usually you'll learn about a few in your coding courses. You'll have, let's go ahead and give us an extra little comment section here. Data types. You've seen that we messed with Booleans, which would be true or false. You have integers, which you might have heard about a lot from your high school math classes. These are essentially positive or negative whole numbers. -1, -2, 0. 0, I can't see my keyboard past my microphone. +1, +2, so on and so forth. There's also a few different names for essentially decimal points or more complex normals. Not normals, numbers. There's a number of different names for these. Some people call them doubles. Some people call them floats. What else do we have? Some people call them longs, shorts, so on and so forth. And there is a difference between all these, and it's how much memory they take up. We only really need to worry about that for other coding languages, as GameMaker Studio will basically, it actually handles every variable interchangeably. So in this case, well, it handles all the number variables interchangeably. Strings are a different case. So, doubles, floats, longs, shorts, you would know them as decimal numbers. This is where we can have a 1.0, where we need to know the decimal, 2.3, 3.14, so on and so forth. That's what we use for our gravity here. This is a double. Or a float, which is usually short for floating point. And it's called that because of how those numbers are stored. And for the moment, we're not going to get into the intricacies of that. Now, there's other data types when you're not messing with numbers. Welcome, Siphon. We're about 20 minutes in, and we've already actually implemented our double jump. That only required about 5 lines of code. Would you like me to go back over that? While I wait for your answer, I'm going to go ahead and say the other data types we can mess with are characters, which are usually shortened to char, and that is basically single letters. I don't think Game Maker Studio has a way to read specifically characters versus strings, which you can essentially say are sentences, words, so on and so forth. You know, quick, brown box. You can put any character in here. Even numbers will work. You notate these by surrounding them with, in the case of strings, quotation marks in most languages, or a character if you're signifying a single letter. You can do that with just the little apostrophes here. And the reason you have to notate these like so, like how there is a decimal here, or true false, which do not have quotation marks or apostrophes around them, is sure, you can go ahead and tell what you're initializing, such as, oh, what is it? Name equals Xander. So you have the quotes around here, which are not actually read as part of the variable. The quotation marks here basically say, okay, this is a string. And so later when you need to call it, your code knows to interpret it as a string because you put quotation marks around it. You'll see that the text here is yellow, and that means that it is being read as a string. Whereas if we just typed Xander, for example, it should highlight blue in a moment. We're getting an error thrown. So let's go ahead and say name equals. There we go. There, we have blue here because it's believing this to be a variable. And that's because of the absence of quotes here. What we will be going over today, for the most part, will be string manipulation. Essentially, how you can work with long bits of character text. Before we proceed, Siphon, would you like me to go over the double jump that we implemented? Very simple, very short. We have a double jump here. Also, our little boy is very cool for helping us, so he's put on sunglasses. Because he deserves it. Alright, so simple enough. We only really needed about 5 lines and a couple of code updates to get our double jump implemented. We wanted to have a different speed for a double jump, as a common rule of platformers is to give you a smaller jump in the air. You might not notice this if you're not paying attention to it. Then we need a jumps used variable, which is how we track how many jumps we have used while we're in the air. So, there's 2 things we need to do. One is check for if we have a jump available in the air. And the second is reset the number of jumps we have available every time we hit the ground, or whatever other condition you'd have. Getting hit or getting a power-up if you're making a platformer hell kind of game. You can refresh it if you touch a wall, for example, if we're doing wall jumps. So, you might remember a code here. This is the code that checks if we are touching the ground, if there's an object wall 1 pixel below us. We have appended only one line here. Jumps used. We reset this to 0 every single time we hit the ground. This essentially refreshes our double jump. We can go ahead and paste this anywhere else that we want to have a double jump refreshed. I've gone about 30 minutes without taking a drink, so real quick break there. I'm going to try to be a bit more patient as we have a lot of complex stuff to cover, and I do want to make sure I get my hydration. So, here is our jumping code, as you should remember. We implemented a... Oh, glasses are shining just because I was getting a little bit smug with my implementation there. Thank you for reminding me. Sometimes I neglect to notice when I'm getting a bit too powerful. So, keyboard check pressed, or W. This is the first check, and this is just if we're pressing the W key. You can see that we have a string here. All the letters here are interpreted as strings by the ORD function. So you had a little bit of a sneak peek last lesson. What we did was we changed the second half of our check here for when we're jumping. Now, there's 2 times we want to run our jumping code. Either if we're on the ground here, grounded equals true, or if the jumps we have used is less than our maximum allowed air jumps. You'll see that we implemented an air jumps here variable, which determines how many times we can jump in the air. Just for a laugh, we'll go ahead and set that back to 5. So, there's 2 situations. If we're on the ground, or if we're in the air. Now, we don't need to specifically check if we're in the air, because that's already handled by the OR statement and the fact that grounded equals true. Essentially, the OR here is not an exclusive OR, like what a lot of people will interpret an OR as. A or B. And a lot of people will think that as either A or B, one or the other. The way programming languages handle it is an inclusive OR, meaning either of these can be true. It doesn't have to be one and not the other. If both of these are true, it'll still run regardless. So if grounded equals true, or the situation here can involve if ground is equal to false, but if we're in the air, the only thing we specifically need to check is if the jumps we have used so far is less than the total number of air jumps we have available. So, here, if grounded, if we're on the ground, else, if we're in the air. If we're on the ground, same as last time, we set our vertical speed to our jump speed. If we're in the air, though, we use our double jump speed, and we increment our jumps used. This essentially means add 1 to jumps used. So that will go up every time we press W in the air. And we can only actually run this code if the number of jumps we have used is less than our total allowed number of air jumps. Now, you'll see that we gave ourselves 5 here, so we should be able to jump 5 times in the air. 1, 2, 3, 4, 5, so on and so forth. And if I mash the key, you'll see he doesn't jump anymore after that. So, there we go. In only about 5 lines of code or so, we have a double jump implementation. Do you have any questions, Siphon? As well as anyone else before we proceed? Now is another good time to take a drink. And while we do that, I'm gonna pop out and get a bit more water so I can be prepared, and I might actually just slow down this next part quite a bit so that we can handle a very, very dense bit of code. And resume. I have set a bit more tea to brew just in case we do have a much longer lesson tonight, which we probably will. So, strings are essentially sentences, and you can just use them for words or lots of different statements, but basically, it is a block of text that you want to read as text. You can't immediately run number operations. You can't say, for example, Xander plus 1. That doesn't make any sense. There's nothing better than Xander. You can do plus or minus multiplication operators and so on and so forth on numbers, but strings you have to handle much, much differently. And there's a lot of documentation for that. Let's go ahead and open that manual. See if I can separate this from the rest of the web browser. I just No, get that off my screen. I said get that off my screen. That's a joke you'll see here in a moment. Hope you're ready. Yeah, still not going away. Hold on, I'm gonna need a little task manager buddy for that one. Exit out of Clip Studio Paint. I'm done making my thumbnail. And we'll need to resize our window a little bit, since I just noticed that we are actually still off a little bit. Change the size of that. Move this over here. And there. The entire thing should essentially be readable here. So let's go ahead and open up that little web browser. Here, even though it's zoomed in a bit too far, there we go. So let's look up strings. And we can see what we're doing. It's just nothing but functions over here. That's the function that turns something into a string. Here we go. Here's our mainstream page here. Those of you who have any coding experience will recognize the hello world here. This is essentially the first coding project anyone does, is the hello world. You just make a program which outputs hello world to a console, and that's the end of the story. Sometime you'll use text, which, you can use for dialogue and a whole bunch of other nonsense. In general, a string can only be created by adding a text within double quotes. You cannot split the string over multiple lines. And as another little thing, part of the example here, if you have a backslash preceding a character, it will ignore the next one. That's how you can actually have quotation marks inside of a string here. This hello world will output without these little backslashes here, and will actually have quotation marks show up. And it has a number of other things here, and then it should show, here we are. So you'll see these are a lot of functions we can use to mess with strings. And I'm going to show you a few things that we can do with it. Here we have ORD already, which we should be familiar with. It takes a string and puts out a Unicode. It essentially turns a string off of a lookup table into a number. So we'll be looking at this very, very soon. That's a little bit of an introduction to strings. I'm going to show you how we're doing things with them. But overall, you should understand strings basically mean sentences, words, or text in general, and how you want to manipulate it. The other thing we're handling is arrays, which is how you can group multiple variables together in a list of sorts. The way you notate that, and I'm pretty sure it's the same as it is in other languages, right? Indeed. So you do array and then use square brackets. And what this does is the brackets here signifies the position or how many spaces you have in an array. An array is just basically a list. So you can say 0, 1, 2, so on and so forth. So the array here will be a list, and whenever you call it, you manipulate the position here, and then you can have it return 0 or 1 or 2. One way you can think of strings is as an array of characters. So these two have a lot of intermingling with each other. If you want to use an array for just numbers, for example, then that'll be a lot simpler than if you want to mix letters and characters together and essentially make a string. Now, I suppose we don't have anything further ado. We can go ahead and mess with our command input code. I have my second example over here on my alternate screen. And just so that I was properly prepared, I do have working code here that we will be copying off of. I will be going over this line by line, and I will be explaining every line as I write it down here. Also, the most important thing, I told you last stream how important it is to comment your code. I wouldn't know the exact intricacies of this if I didn't write comments. So now it's a lot easier to keep a reminder of what exactly each line does. So, we want to do a dash, right? Oh, wait. I moved the wrong window back. We want to do a dash, right? So that means we're going to need to detect the same input twice quickly. And we'll use our command interpreter to do that. So what we're going to do is use a very wonderful thing that Game Maker Studio lets you do, and we're going to create a script. I'm going to go ahead and call this command input. That's all we need for the name there. Function command input, and it goes on like that. I'm also going to teach you about how we do some scripting. The reason why we want scripts is so that we can use the same block of code in multiple different places. Similar to how we had constants here, we want to rewrite our code as little as possible. And if we just have our command input function here stored as a script, whenever we change the script itself, it will change how it works for every other time it's called. What we've done here is essentially just put all of our code here in the step event of our main character, but it would have been better to put it as a script, say, if we wanted to make other characters that behave similarly, but not exactly the same as our main character here. If we updated code here for Blocky, it wouldn't update it for any other characters since they are not running off of a script, essentially. So here we go. We're going to need a variety of arguments here. This is a script, so we have to tell what we plug into it. Some scripts don't need things to be plugged in, but whenever you plug a number into a script, they're called arguments. So we need to write in argument 0, argument 1. Okay, we need 3 of them. Argument 2. In just about every coding language except for MATLAB, which MATLAB is horrible, you start lists at 0 rather than 1. And let's go ahead and copy this over here. The little comments here actually change how it is read from using the code. These aren't actually read by the engine, but these are used by your IDE, your development environment. So for example, we have keyboard check here, and you'll see this little spot right here. It tells us what arguments we used and describes what we'll need. So say, for example, if we did command input, now it will show character, command, and time. So we know what variables we need to plug in when we call this script in the future. Now we need to set up variables. We have a bunch of variables that will locate or will allocate only for the duration of a script. We don't need to save these after the script is done running. So, character equals argument 0. Looking at my code that I have over here, I do believe right. So character here is who it reads from. This way, the way we have it set up, we determine where we can read inputs from, and essentially, you can read the inputs of other characters. Say, fighting games have something known as grab teching, which is when two characters grab at the same time, or if you grab slightly after you get grabbed, you break free of it. That's how you essentially beat grabs, is by predicting when it's going to happen and attempt to grab your opponent at the same time. This, the way we have this set up here, lets us read commands from anyone. We pass along a character argument here, which is who we read the command from. And in 90% of cases, it's just going to be ourself, whatever object is calling the script. Var command, reading off of my code here, string explode, comma, argument 1. This is not going to initially make sense. Here, oh wait, that's another script I used. that isn't a default script being handled by the game, by Game Maker Studio. So, quick detour here. We're going to put another function inside of a function. Let's go back to my scripts here. String explode. Now, in a lot of cases, if someone else has handled the problem you're trying to tackle before you did, then it's okay to steal code, so long as it's credited or something that's common knowledge, essentially. Call this string explode. And this is a custom function. This is how we'll be messing with strings. So, this looks like a load of nonsense, doesn't it? Get that out of the way. Get rid of the extra curly brace. Everything here should be fine, right? There we go. So, the fella here who wrote this one out did leave some comments for what they're doing. String explode. This is a custom script, but this is how we are going to mess with a string. Converts a string of data with elements separated by delimiter into an array of strings. See how it's all coming back, right? What this does is it will take a certain type of a formatted string and split it up into pieces separated by character. First thing is the separating element, and then second here is the data. We don't really need to know what this code does just yet. We're blackboxing the script, so we only need to know what it does, not how it does it. The return here is the only thing we need to focus on. So you see we have a lot of code going on here. The important thing is the return. What return means is it is what a function gives back to you after it has executed. Let's go ahead and save, and there we go. This is now highlighted in orange, meaning that it is being interpreted as a script. So what we do here is we call a function, the function of this script executes, and then gives us back a piece of data. So what this does is it will, for example, input a string with a variety of separated characters. So let's say A, comma, B, comma, C. And then what it gives back to us, the return, is a string array, which basically lists out A, B, C. What string explode does here is we'll plug it in something with a certain character to delimit it, or separate it, in this case, commas, and then it gives us back each of the separated bits of the input. And this is how we're going to read our command inputs here. So, all of you know, or those of you who have been watching this enough, should know, let's say, Shoryuken input. There you go, we have a bunch of different examples here. The infamous Z symbol, we have a bunch of different little examples that have arrows here, so long and so forth. The Hadoken here, down, diagonally down and forward, and then punch. So what we'll do here is we'll separate this into a variety of different sections. We can feed our command interpreter a whole block of a command, and then we'll split it into separate little pieces. And I'll show you how we're doing this. So, this will take a typed out command, and for the duration of the script, we will separate it. On to the next line. This is going to be very slow and very tedious, but it's really, really cool, and I wanted to show this off. I wrote this like 3 years ago and haven't had much of a reason to use it since. All right. Bar time equals argument 2. Simple enough. This is a limiter of how far back we want to read our command. Essentially so that we restrict it to where you have to input the command quickly enough, and say if you don't do something like crouch for a bit and then later walk forward and punch, that it doesn't read a Hadoken, as you didn't try to quickly input it. Next up, bar. This is where we set up a number of different things which do not handle arguments. There's that I again. We're going to be working with for loops in here. Our search step. I'm going to instruct what we do with these when we get to them. Let's go ahead and separate these here. Used for the script. And take our input. Does everyone understand what's been going on so far? How we feed arguments into a function, how we use a function, and how we allocate variables, and what the string explode does here. Is everyone good? We clear to go? All right. It'll all make sense here in a moment. So, let's go ahead and I'll just go ahead and copy the comments that we have here and then explain the code while I'm typing it out. So, while search time is less than time, what this line means is while we are looking in our command, you started to get into coding and then math happened. Sorry, coding is entirely math. It's an exact science. Welcome, Kyle. Have you just arrived or have you been here for a while? We're actually starting on working for a fighting game input interpreter here. History. For a certain time. So you remember the for loops that we did, right? We did for loops here for the collision. Yeah, for the collisions here. This is similar. For and while are two different ways of handling loops. And a while loop is essentially a for loop, but with this third part removed. Want to stop by and say hello? Well, welcome, Kaio. The VOD will always be up on YouTube, and do stop by later as I show the fruits of our labor. Goodbye, Siphon. And good night. I hope you at least know what to do with the double jumps, but I will show off dashes here in a moment, and a couple of other tricks, once we have the implementation here done. But thank you so much for the attendance. Search time plus equals character dot. What? Really? Hold on. When did I assign that variable? I think we're actually getting into variables that I assigned. Oh no, we're going even another layer deep. Now, that's for our command inputs. You know what? Hmm. Fine, I'll plug in my controller since that's how I got this to interpret previously. Go ahead and grab this, grab the gamepad. Plug that in here. And we might be getting into a bigger depth than I previously anticipated. So we might need a diversion here. Let's see here. Indeed, before we start reading it, we're actually going to have to start writing the inputs. That's correct. So we're going to go ahead and make two more scripts in here. Input initialize and input get. All right, simple enough. We'll go ahead and black box a bunch of this code here. We're going to need these scripts for what we're working with in a moment. In welcome decursion, we're messing with getting controller inputs right now. So we're going to black box this one as well. I don't need to describe the exact intricacies of what's going on here. But what this script does is it starts us off with an empty input. And we'll be using this for our input get function. And this script is going to be very, very long. Welcome, Shika. How are you doing this evening? I don't need that. And don't need these two lines either. Of course I'm joining the tourney at Strive. That's the only fighting game I'm regularly practicing. So of course I'll be there. So, as part of our command interpreter, man, we're just using so many different variables here. Let me go ahead and grab some of the other things we had. We had a control, right? There we go. Met a new scientist. Do tell me who, Shika. Let's go ahead and we'll need another little constant here. Couple of constants. So you do know that we have our constants for our character specific here, but we're also going to need some globals, which can be read by anyone. And we're just putting these in as the amount of sensitivity we have for a dash, the buffer and freedom we have for inputs, and the sensitivity of our stick. Having to go back and dissect my own code. So it's bits and pieces in here. So what this is a long block that takes the input that we give off of a controller and then returns a string based off of what we input. I don't have comments on this one, but this one's pretty straightforward. Like what we had with our character here, let's go ahead and look. Like what we had with the keyboard check ORD type of stuff, this is checking if we pressed A on the keyboard, and we're going to go ahead and upgrade to a gamepad here. The gamepad button check looks for a controller that is plugged into the machine and gets the inputs accordingly. This is our horizontal input, this is our vertical input. This takes in our left or right, and this is up or down. And this checks our buttons. So, this is the important part. And I didn't think we had to get here yet, but it's a good part for us to go ahead and interrupt this every time we're going to need to do some other part of the script. Here is essentially our first complete block of code that we'll need. What this does, we'll go ahead and comment this out line by line. Give us a blank input for this frame. We start out with nothing, and we're using numpad notation here because we are an anime fighter player. If the horizontal input is equal to our facing, meaning if we tap in the direction we are looking, numpad plus equals. This adds on an F to what is otherwise an empty string. So where we would initially have a blank space, this says if we tap in the direction we are holding, add in an F. This one here will look further back in our command queue and append a different little thing if it is a press or a release. Is string count another one of our default functions? Let's go ahead and head back here. No, not GML reference, string reference. Yeah, string count. There it is. Return the amount of times the substring appears within a specific string. This is one of the most important things we need to do here. This essentially, string count reads a string and returns if it finds something. So, if we do not read a previous F input, and we do not read a previous reverse input, then we put in an asterisk here, meaning this is essentially us tapping forward for the first time. This is how we can do something similar to a press rather than just checking if we're holding forward. And we'll actually use this as part of some of our important commands. Then we basically have the same thing in the reverse direction here. If we tap in the opposite direction, then we put in an R instead. Same thing here, except we don't need to check our facing, so we just do if we hold up or if we hold down. Then we add in a U for up or a D for down. So this is how we'll actually put in our inputs. Who here does not know what I mean when I say numpad notation? This is a very important lesson. This is how a lot of anime fighter players discuss their inputs. Essentially, like it's read off of a number pad. Facing right, if you are not inputting, that is considered a 5. You'll hear me say a lot of things on stream like 5p, or 6p, or 2p. And that is signified by the directions that we are holding on our stick. A 5p means I'm hitting the punch button with no input. A 6p means I am pressing forward and punch. A 2 means I am pressing down and punch. And here it has a list of commonly used inputs. Here's a Shoryuken, Dragon Punch. Here's a quarter circle forward, also known as a Hadoken. Here's a quarter circle back, known as a Tatsumaki. The way we settle this is a bit different than numpad notation, but it works very similarly. If you imagine it as a numpad, fighting games basically accept a neutral direction or one of 8 different directions. We'll go ahead and do a block here. So we can do reverse up. If you're holding up back, this equates to a 7 on a numpad. U, which is known as an 8, or FU, which is forward up, also known as a 9. Then we have R for reverse, N if it's completely neutral, F if it's forward, down, revert, or reverse down if we're holding backwards and down if we're holding only down, and then forward down if we're holding, well, forward and down. I actually should put that after here. That's why we have the addition here, because the code will go here first and check if we have a forward or a reverse input, and then it'll give us the horizontal amount. Then it checks if we have an up or a down input, and then it will add that on, which is how you get the corner inputs here, which are 2 characters long, rather than 1 for the rest of them. What this block does is, if we have input nothing, then go ahead and type an N in there for neutral. Is Xander going to do a pretzel? We can input a pretzel, but we'll need to actually have a move for that, and I don't have an animation made just yet. Possibly here in the future. And I believe... Right. So, what this does, you'll see the exclamation point is here on the first third of the statement, but not here on the other ones. What this block does is check for released inputs. What this does right here, if we read an up, if we do not read an up input, but we do read a previous up input in the previous frame, and it is not a released input, that's what we're doing with the little squiggly here, then we add a release up into our string. So essentially, this will add on to our input whatever inputs we have released from the previous frame. And this is actually one way we can detect for dash inputs, or other little gimmicks, such as if we start an input with releasing down. Does everyone have a basic understanding of this part so far? It's very complex, but essentially what we are doing is we're taking an empty little string, we're getting an input, and say, for example, if we hit forward, we add on an F. If we're hitting down, we add on a U. If we were previously holding back, but released it, then we do R. And what's that called? That's called a tilde, right? We add on the released input. If we get nothing, then we give it an N. Essentially, what this does is it adds to the start of our input what directions we hold. And then we use the same notation for each of our individual buttons here, which this is going to be a lot easier since we have functions to look for actual button presses, button checks, and button released. What we had to do here is essentially we measure a joystick input. And because that requires an analog input, we need a lot more complex code here, which checks our previous inputs. But here we have direct functions implemented by the engine to check, oh, did we press it this frame? Has it been held down? Or did we just release this input? And then same thing here. We append these characters onto our input. So here we might have, for example, if we were pressing, say, 6p, it would come out as F and then X asterisk. Welcome, Pakin. We're going over fighting game inputs as we're making an interpreter here. This essentially means 6p, or we have been holding forward and just pressed X on our gamepad. And this one, okay, so what this does is it checks for differing inputs. I can actually go ahead and boot up, say, King of Fighters, for example, as a good demonstration. In fact, that might be a good thing to do in the background real quick. Let me go ahead and boot that up, get you off here. Let's go ahead and boot up King of Fighters in the background, and we'll use that as an example, although that's probably going to take over the stream. So while that loads in, I'm going to go ahead and take another break real quick.
KOF 15.
All right, so we've made our return here. Hopefully the volume is relatively quiet. Yeah, Shika, we're gonna go ahead and look in KOF 15 for an example. Oh, that's still on the wrong sound device. Let me get out of that. change this over to my sound settings and boot that back up. So what we're going to do is looking at an example from King of Fighters over here, which has a very, very good training mode. I probably should have led this section with this, as this is a much more important component of understanding why and how we're doing this. In fact, I'll probably just leave this up in the background. Let's go ahead and head into training mode. And pick my boy Terry. So, here in training mode, we actually have a very good example to pull from. If you look on, see if it's actually showing on the left side of the screen. There we go. Okay. So, I want all of you... Can I draw a little rectangle here? I want all of you. Okay, it's still capturing my mouse at least. You see over here, where we have the dot and then an incrementing number. Well, what if I hit forward? There! It has a forward input. And then a 16 next to it. Then this one keeps increasing. You'll notice that number is always increasing. And that is basically a measure of how long you are holding a specific input. If I go ahead and hit a button, it'll register those inputs as well. If I hit multiple buttons, it'll read multiple ones at once. If we move and hit a button, it'll add them on. So, what we're doing is essentially replicating this. Now, here, we have a list of variables. And what do we know about lists of variables? The commands here are an array. So I'm going to go ahead and mute that audio so we can get back to the code here. Essentially, similar to, can I have this in the background and then just move this over here to the side? There we go. Okay. So what we are doing is like what you see with the null input here. We have different icons being added on whenever you hit certain inputs, which is exactly what our code does here. Start out with a blank space, and then add on whatever inputs we read. That's what this is doing, and that's what our code is doing here. The last little thing we're doing here, what this does, is it looks at our command array and checks if our inputs this frame are different from the previous one. You'll see how the 2000 over here is increasing over time. That's because we're not inputting anything new, so we don't need to put anything different in the queue. That will change every time we input something, be it movement or a button. And the number you see next to the input is a measure of how many frames that has been going on. So, this will update our command queue if our current input differs from last frame's input. And access queue is probably a bad name for a variable in retrospect, as essentially we're getting more than just a queue of axes. The whole access queue thing here, you'll see we have another for loop. The whole access queue thing here is our input history, which I believe I had assigned from one of these here. Let's go ahead and double check my other code here. Ah, okay. So, this is our script that gets our input. This is what initializes all of our input testing variables. So we'll need, looking off the example that I already had here, our little character here, for the very first start that he makes, is going to have to call input initialize. There. Which I guess we'll take a quick run through here. What this does is all the variables here determine if we're inputting up, down, A, B, X, Y, all that stuff. The current input will always start with neutral because that's what happens at the beginning of a match. Axis Q length. This is the length, or more essentially, the number of commands we have. Axis Q equals array create. Remember, this is an array we're messing with. This is a list of different variables that we have input in here. So there's the first array we're creating. In axis Q time, I believe. Okay, yeah. We are creating an array here. This one is our input history, which we have separated from the amount of time we've had our inputs. This essentially here is, let's see if I got Alt Tab out of here. There we go. Do I have my mouse back? There we go. Okay. So we have two arrays here. We have the first part here with our commands, and the second part here is how long the command has gone on. This one here is our actual inputs, and this is how long the inputs are. And we have them separated because we don't want them to mess with each other. We read them side by side, but we don't want the duration of our inputs to show up in the actual part that we're reading inputs from. So here we initialize two separate arrays here with a length of 60 that we assigned here. And you tell me if we ever need to actually have a command longer than 60 inputs, which I don't think exists. In fact, I don't think we'll need to go more than 20 ever. So we essentially have two arrays. One array, which is a list of our inputs, and then a paired array that actually has a lot of interactivity with it. Second array shows how long we've made these inputs. And if we go back here to input get, what this does is the same as the little code block there is the same as the update every time you see a new number start ticking. If you look on the left side of the screen, you'll see it resets back to 0 every time, or resets back to 1 every time we do a new input. And then it bumps everything down in the queue, as we're essentially just getting a reading of all the different inputs we're doing. If we change our inputs frequently, it'll go through that queue much quicker. So, if x is q0, you remember these square braces, right? This looks for a certain spot in our list. If what x is q means is the first spot in our list of commands, if it is not equal to our current input, then we do another for loop. You remember these, right? For initialize I to be the length of our command history while it's greater than 0 and while it decrements. So basically, for every what do we call? Every element of the input array, essentially we copy over the furthest one back and then bump everything forward. You'll see the list of inputs here will bump everything down as a new input comes in. That's what that little bracket does. This will iterate through every element, set our furthest back position or furthest back input to the one in front of it, and do the same for input history. This essentially bumps down every element and pushes in the new input from the currently running queue. Then we'll go ahead and set our current time in the history. That is the number here on the right, the one that's currently at 2,800 and counting. We set our current duration to 0, and then we set our most recent input to whatever we read off from here, from all this block up here, which will look something like this. So we've gotten a queue here, which shows or creates and modifies an array depending on our input for a controller. Does everyone here have at least a rudimentary understanding of where we are now? I'm going to go ahead and get that interpreter over here. And I'm going to go ahead and copy my draw functions. So that we can actually have a visual read. And there, I think. All right, so draw GUI, and I'm just going to copy this from my other bit of code. We don't need to know exactly what's going on here. Find and replace every instance of object player with object character. There, hopefully we don't have any errors being thrown. Just that one for the last bracket at the end, it looks like. Ah, we have a list of draw sprites here. Because I made silly little button icons for when I was doing this last. We'll just replace this with draw text. All right, yeah, I think we can actually just copy this over. Change these all to. Is there a draw text? There we go. I guess we don't actually have to worry about this just yet. Let's at least run it and make sure it doesn't crash. I do believe I made properly scaling GUI with it, right? What do we have wrong here? Our bracket should be right, right? Oh, we didn't actually finish our command input code. Let me fix that real quick. Well, actually, we're not using any of this yet, so let's comment that out and see if our debug draw functions work. Of course. Anyone have any questions so far? Right now, I'm just messing around with a couple of view variables. All right, KOF still blasting music in my ear. It's a bit hard to think. All right, you know what? We'll just skip that and go back to something simpler. I'm going to show you exactly draw text. Let's say 0, 0, and then axis Q, 0, and then slightly underneath it. I don't think we need all the fancy schmancy input stuff going on. Now, we don't actually have our character doing anything with the inputs being given to him. Hmm. Doesn't seem to actually be. Oh, right. That's because we didn't actually have the code in here to read the inputs, right? So we'll do that, and then hopefully we'll have a demonstration of just what is going on here. So at the beginning of our step, just say input get 0. There we go. Okay, let's go ahead and get ourselves a larger font in here. Create a font, let's say Arial, and then size 90. Draw, set, font, font 1. Welcome, Sochiel. We were just testing our command interpreter. That is still far too close, so let's bump you down to 100. We have the first element of our command interpreter working. You'll see that the large number we have in the top left is an N if we're not doing an input. I'm going to go ahead and hold forward. You'll see it started out with an asterisk for 1 frame when we just pressed it. And when we release it, it had an N for neutral input, and then an F with a tilde for our release. If I spin the stick, it's going to queue through all those commands there. Press X, release X, Y, B, A, press them all at once, and then spin the stick. So what we're doing here is our commands are being entered in as a string based off of what we've done so far. And for some reason, it's not bumping back our commands. This should be changing. Let's go ahead and put a little red dot here and see if we actually come across this code. It's never actually running across here. Let's go ahead and set this back to 1. Oh, right, that's stick sensitivity. That's what that's for. I wonder why it's not bumping back the other inputs. We should have the variables assigned correctly, right? We're not getting anything changing, though. Better than the first. Welcome, Broham. We're working on our inputs here. Although we have gotten past the point of discussing the initial use of the inputs there, and how they relate to strings and arrays. Now we're needing to actually make commands happen. Although it's not actually bumping back our command for some reason. So whenever we put in a new one, it's not updating our current queue. Initializes input. Yeah, it will take a lot of catching up. I think we might be at the point where I need to gather my notes for the next part, as we did get a little out of hand at the end there. Perhaps I'll make a duplicate of this project with the actual finished project, and then work backwards from it. I did use the previous game I've made, which actually had a working command interpreter, but it looks like there's a lot of different variables just for the convenience of showing you all. I might have to update and change for next one. We might be roughly done with the lesson here, since there's a lot more I need to do to actually show you what we're getting done. Let's actually go ahead. Let's see. Draw text. Let's go ahead and set that to 500. Change our font size here to 60. And let's do a little for loop. Equals 0. I is less than 60. I plus plus. Then we'll say 60 times I. And what this should do is actually give us the entire queue written here in the GUI. Oh, what are you missing? Oh, I put in a comma there. There we go. 4 statements are written with semicolons. Right, we'll need to plug in I there. There we go. Okay, so strangely, it's not actually modified. Wait, that's why. Okay, really, really simple. We need to actually manually increment 1 onto our current input time. And there, okay. There, now we have it working. Let's go ahead and bump you over to 500. So the star means the beginning of an input. There we go. Now you see we actually have a readout of what our inputs are doing. Now we have the same thing as what we had in the King of Fighters example. You'll see we have a neutral input here. That number is counting up. We press forward. It's going to have a star on one frame, meaning we have just started pressing that input. And then now that we have it held down, it's going to keep incrementing that without the star. When we release, it will have a tilde. This way we check when we press an input or when we release an input. And here we have me spinning the stick around. So see, we have a very small amount of time that any of these inputs stick in. Then, of course, we add on the button presses for whenever we use them. So here we have it, a string and an array. Now we have the game inputting commands. But we might actually have to take a little bit of time. You know, we can work on the second half now. Now we can get it to read. Let's go ahead and see how much code we're having to work with over here on the side. Yeah, that's not much at all. Okay, so this is not going to be an issue for us. Resuming where we left off, we got a little bit ahead of ourselves. So what this whole function will do is read down the list in the history. Axis Q time. I. So, while we are looking in our command history, we are going to take the number on the right here, the duration of our command, and we're going to add that to how long we've been searching. That's what this block means. This is to limit how far back we search. Welcome back, Will. We're working on a fighting game interpreter. Var search q equals array create I and then blank. Or essentially an underscore. Not quite blank. This, oh, that's not a semicolon. Create the, this is essentially a subset array. This is another array based off of how far back we're reading. I imagine it was rough. Well, we might have some better luck here. I do have a lot of experience with GameMaker. So, what this does is it searches back the amount of time we are allotted. While the amount we look is less than the time that we pass to the function, we're going to look back and we're going to create first a blank array, and then guess what? We have another for loop. J equals 0. J is less than the length of the array. Array length 1 dimension. Search q. And then add to it. Again, a for loop. This is for us iterating through every section of the array. And here's what we do. We fill in the queue backwards because this is how we'll read inputs. So the input history essentially is listed like this. Most recent, second recent, third recent. And the way we write out commands, we're going to go ahead and I'm going to go look at the example we have here. And let's see where I have that. Examples of us pulling out a command input. Ah, perfect. So, the way we'll add in commands, for example, with our dash input, we will start with a F star, meaning we start a forward input, and then an neutral input, and then another F star, meaning we just tapped forward. That's how we enter in commands. It might not be a good example here, given that this is a symmetrical input. Let me go grab, say, for example, a QCF. Okay. So a QCF will look at D. We tap forward while holding D, and then we're holding forward, and then X. This is what a QCF would look like. This essentially would be the equivalent of A2, comma, 3, 6, X. The reason we're feeding this in backwards is because our queue is listed as most recent, then second most recent, so on and so forth. Third recent, and like that. So the command we're looking for, while we're adding it here to the search here, we start from the front. This should be our most recent input, our second most recent, third most, and then fourth most recent input. Go ahead and comment all that out so none of that compiles. Let's bring back over our command input code here. Search queue, array length, one dimensional, search queue, -1 minus j. This essentially just means a step in the opposite direction. Hence, we have all the subtraction here. We are starting from the end, which is what the -1 here is, an array length of 3 would return 3 here. But remember, indices start at 0, so a 3 length array will have 0, 1, and 2. The array length here, -1, means at the end, minus j is minus how long we've been searching. Finish off the array search there. Character dot sysq j. We fill in our search queue backwards, the furthest back position, to whatever is our current most recent input in our input history. And then when we look one back in here, this will be our second most recent input, which will be put second to the back of our search. Now, this is where we get to the nitty-gritty, which is surprisingly few lines now that I'm looking back at the code here. We'll do another for loop and a break. So, typing it out one by one. If array length one dimensional of our queue that we are searching is greater than 0. I didn't have this exact line commented. Okay. So this is a stopper right here. If the number of inputs that we've most recently made is greater than the total of number of inputs that we're searching for, this means only start searching if we've made enough inputs lately. For example, if we're only holding forward, and we do that for a long enough time, we haven't been making a lot of different commands. The QCF here relies on 4 different commands. If we have not recently made 4 different commands in the amount of time that we're looking for, then it would be impossible that we've input a quarter circle forward at all. So this code only executes if it's even possible that we've recently made the command. Now, we do hello again. It's another for loop. We're going to iterate through an array again. For k equals 1, k is less than command 0 plus 1, k plus plus. The reasons we have the +1 here is it has to do with the positioning that we'll be searching through the arrays with. You'll see we have a lot of numbers here in between the square brackets. The position in the array that you look for is equivalent to the number that we have here. So we'd be searching. We start at 1 because the string explode script, remember, we started out with string explode here, which returns actually not just our split up string, but the very, very first one, the array 0, very first element of it, is the number of items read. So essentially we can look for string explode 0 would be the length of the command that we have just read. Starting at 1 because the length is stored in the very first element, so every element afterwards is going to be the actual part that we've split up. And L is minimum of search step K. So L here is the farthest back, or the minimum in our list, that we can look back between our little incremental part of the search here, and K, which is where we're currently looking. This essentially is a limit on how far back we look. Again, start a while loop while the farthest back that we can search is less than the length of our search queue. Again, basically reiterating the same thing. Put in another couple of brackets here. If string position command K search queue L. This looks weird, but this basically means if the part of the command we're looking for is in the search queue far enough back, then found equals true, search step equals L, or in other words, as far back as we have looked, and then break. So we move on to the next element of our string, else. Found equals false. And then L++. Essentially what this does, we'll only start searching if we've made enough inputs for each element of the temporary queue we've made. Look for the farthest back, or essentially the closest element between how far back we've searched, which is search step, or K, which is something we're comparing to search, or search step is being compared to K. So while we have not reached the end of where we're allowed to look, meaning this entire block is going to terminate once we get to the end of the command we're looking for. If we have found the input we're looking for, then found is true, we go to that element where we've found the input, and then we break. So it will move on to the next element of the command. If at any point we do not find the input we're looking for, found here will be set back to false, meaning it's going to set it back to false if, for example, we do a quarter circle forward, but not the correct button. L++. That's where this comes in. If found, with the exclamation point in the front, that means not. Exclamation point at the beginning means is false or not. If we haven't found a proper history so far, then we break out a loop altogether and we say, no, we have not found the input. Scroll down here to the bottom of this. Then return found, which is a Boolean. This is a bit of a doozy. But what this means is we take who we read the command from, the command we're looking for formatted as a string, and how far back, basically the tightness we're allowed of the input. While we are going to go ahead and make a second array here, which only goes as far back as we are allowed to search, only as long as we have the tightness of our command implemented. We'll create another array, but this time backwards, because what we're reading from with our elements here, the first element, down, second element, down forward, third element forward, fourth element x. This is actually written in for human readability, which is the opposite of how the actual input array would be read, which would look more like x, f, f star d, d. This is what the data is stored as, and this is how we read commands. So we build it backwards. Then we create another array that's only the size that we're allowed to look back. This is where it's actually being filled in backwards. Now, found is initially false, meaning that we haven't found the input that we're looking for. If we have not even recently made enough inputs for it to be possible, then we terminate and we return false. No, it's completely impossible that we could have even made enough inputs. So, no, we're not even going to try to look. But if it is possible, then we look at the temporary reversed queue that we have here. And if far enough back we have the correct input we're looking for, the reason we have the minimum here is it starts us at a certain point in the array for each command that we're looking for. We have this set up to allow a bit of leniency. You don't have to exactly put in down, forward, and then x. You can have other inputs in here. But we're essentially going to read, okay, did we most recently press X? And in a certain time frame, do forward, diagonally down, forward, and down. Be touching on frame data any one of these days. I can definitely do a fighting game specific tutorial. In fact, that's an idea that I've had for a long time, and I do need to make curated, proper YouTube tutorials for that. If you'd like me to, Will, I could bump that forward in the queue of tutorials that we get run through. And that actually is relevant to what we're doing here, as essentially the frame data is comparable to how far back we're looking for this. So if we have not reached the end of our temporary search here, if we have found an input that we're looking for anywhere between now and the end, then we'll say, okay, yeah, we found the first step of our element. Something you wonder about every once in a while. I can definitely give a good instruction on frame data. That's probably the first of fighting game lessons I need to go through. So, if we have found the input we're looking for at any point, then we move to that point in the queue, say, yes, we have found it, and then start over looking for the next point in the command. If at any point to the end of how far back we're allowed to look, we do not find the next part of the command we're looking for, then we say, okay, found is false. If at some point we either reach the end or find the wrong inputs, then we break and return false. So, 2 hours in, and that is a doozy there, right? I might actually try to make a more curated or pre-scripted version of this tutorial sometime in the future. Now, we need to actually use it. So, let's go ahead and say we'll need now a dash speed equals, let's say 20. Twice our usual run speed. Now we'll need to modify our movement code. Yeah, if we are going too fast, then instead of setting maximum, we'll go ahead and just subtract. So this will allow us to exceed our maximum speed for a bit, but return to it slowly. Now, what we can do here is now we actually start inputting the commands we look for. Let's see, go look at my example that I have over here. Now we have gotten over the hard part. Now we just have the fun part. If command input object character, this is whose input queue we're looking at, and we're looking at our own inputs. If we have tap forward, then a neutral, then another tap forward, and for a duration of a maximum of, let's say, 15 frames. Then we'll say HSP equals, we had a dash speed, right? Yeah, okay. Dash underscore speed times facing. Set, I said comment, set our speed to our dash speed in our current direction. So we're looking for forward, or what this input will read is tap forward, no input, and then another tap forward. Let's give it a test. Ah, is there another variable I need to initialize? Ah, it seems there's a couple of other scripts I need. Character initialize. Input initialize. Really? Where is that variable first being listed? I might have missed that. I might have missed that in our script. Where's that first set? No, it should be here. So it says we don't have a search queue variable set, even though we're setting it right here. They might have actually changed some of it in one of the recent updates. At line 43, oh, we might have been put an underscore here where we shouldn't have. Okay, I think I have it. There it is. Okay, here's our culprit. We put in an underscore. It is a typo. Nothing's wrong with our code, we just made a typo. So now it should work, right? Ah, so you'll see we didn't even update our inputs to accept inputs from our controller, which actually makes it much easier to test. I'm going to tap right twice. Nothing happened. Now I tap left twice. There's a dash. Have him facing right, tap right twice. Now he moves that way. If we do it slowly, that one doesn't count. A little bit quicker, and that one does count. If we do back, forward, nothing. Up, down, we can spin our stick whatever we want. If we spin really, really quickly, again, no. If we do back or forward, back, forward, again, not working. Welcome, Strong. We actually have just been making a fighting game input interpreter. And we've just used it to implement a dash command. So there you have it. You have to do tap forward, neutral, and then tap forward again within a certain amount of time frame, and you'll get a dash. Now, let's go ahead and update the rest of our commands to change how our character moves. So here, horizontal speed plus equals keyboard check blah 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 blah. We can just use an input now. So let's go ahead and that is our previous movement code. Let's just go ahead and use command inputs now. Now that we have a different function written for it. Input. Object characters input. F1, meaning if within the last frame we've held forward. HSP plus equals sine facing times horizontal friction. This means if we input in the same direction our character's facing, they move forward in the direction that they're facing. If we instead tap reverse, actually, wait. Yeah, we want to do a little else if here. If we tap in the reverse direction, facing equals negative facing. If our facing is currently -1, we make it +1. If it's currently +1, we make it -1. Turn around or move forward. Let's go ahead and give that test now. All right, he still has the friction happening. That's right. So, yeah, let's say if. So now we have the keyboard check, and we're going to go ahead and try to eliminate all of these. If command input neutral, then we slow down. So what was happening there was our character's friction was decreasing at the same rate that it was increasing whenever we started to move. So he still didn't move forward. Except now we're kind of having some more issues with it. Let's see how I actually wrote that over on my previous code. And we'll use that as an example. Oh, okay. We needed to remove that equals 0 at the end. Now it should work. There we go. Oh, and we still need to eliminate our little facing variable here. So there, we have now changed circumstances. Now if we actually hit back, our character turns around. You'll see now we're getting the interpretations from our stick. We have a dash if we want to move quickly. Now we just need to add in a change to make this a jump input. Change our command input here to ask for A star if we have tapped A, which we use for both our regular jumping and our double jumping. And there you have it. Now we have jumping and dashes interpreted with our character getting to use fighting game inputs. And there's me mashing on the controller right there. Any questions? We have set out to achieve our goal, but why don't we play with it a little? I'm going to go ahead and say, indeed, I actually wrote this like 3 years ago, and I've been looking to break it out again. I really would like to do sort of a regular dev stream thing on this channel. I do have game dev aspirations of my own, and something I've been looking forward to for a long time is being able to network to get it to happen. Sprite index equals SPR character. Now let's have a little bit of fun with it. If we're going to use fighting game inputs, we need to have attacks, right? So we'll go ahead and add in another variable, control equals 1. This is if our character has control over their motion. So we need to actually move this out of the way. We'll apply friction after all the other movement. And now we restrict everything here to control and place all that inside of a bracket. So you're not normally able to attack or move around if you're doing something else, right? So we're going to use a control variable, which for now, since we're not using like complex state controllers or hitboxes or whatever, we're just going to have a check on if our character is standing idle. And we'll just start at the beginning of if sprite index, if our current animation is sprite character, control. You know what? No. We'll shorten that down to one line. Control equals if our current sprite is set to the neutral standing one. Otherwise, we're not allowed to do our usual movement. Whenever a different animation ends, we'll set it back to sprite character. So, let's have a little bit of fun. Friction comes after everything else. That's actually if command is neutral, or we don't have control, so if we're not inputting anything while we're just running around, or if we don't have control, then we slow down. So let's go ahead and do X for a punch. If we input X, sprite index equals, and I made a couple of sprites before the stream, so sprite character punch. Simple enough. If we do what? Wait, yeah, Y, let's do kick. I made a kick and a punching sprite for a little fellow. So, assuming everything works properly, if I press punch, he's got himself a little boxing glove. Just a quick 10-minute exercise in futility. And if we press Y to kick, he's going to show us his Tims. And if I so we can interrupt them. You can change from one to the other, and we don't want that. If a character punches, then they shouldn't be able to do a kick simultaneously. He woke up and chose violence. So, now we're actually going to go ahead and put if. Yeah, okay, we need those inside of this bracket right here. There. If we have control, so this way we can't interrupt one with the other. You'll see the entire animation plays out instead now. Also, he's going to slow down if he's currently doing an attack. Even if I'm holding forward, he can't move forward very much if he's just spamming his attacks there. Now, the entire reason why we did this. We're going to need inputs, right? So, let's give him a show you. Sprite character show you. It really is actually, you know what? I'm going to show you the sprites here in a second. Now we need an actual Shoryuken input. So forward, let's go ahead with release forward, down, down forward, and then X. So yeah, that should be a Shoryuken with a punch. And now we'll do another little gimmick. If sprite index equals sprite character Shoryu, HSP equals, let's say 5 times facing. I'm not using a constant there, which is irresponsible. And then VSP equals jump speed. There. So if a sprite. Oh, wait. If sprite index is Shoryu and image index, this is a measure of which frame we're on. If we're currently on the first frame, now we should have a functioning Shoryuken after just a couple lines of code. Oh, right. Hmm. So let's go ahead and look back in here a little bit. So it starts out with F star. Oh, and then we have D star and F. Okay, so we need this to be D star. And then D F star, right? It's just a couple of extra little scribbles on there, Will. Still not working. I see. I think it's actually the order that we typed in some of those characters. So let's say I don't think I actually got Shoryukens working earlier. It might be a little bit more difficult than that. Okay, so let's try it like that. No, we'll need to have this separated. This might not actually work if we're frame perfect. F down and then forward. Oh, okay. This is why. We put the F and D backwards. So it's supposed to look for horizontal inputs before vertical ones. Now it's still not working. Let's just see if we can change that to a quarter circle forward and see if that works. I think it might be because we're going through this code first. So let's go ahead back here and say, and this is false. FD, and then FD, and then F. I think it might actually just be a little bit too strict with the inputs here. This is interesting. Let's actually just do something simpler than that. Let's see if we can just do down and then forward. Oh, wait. No, I'm an idiot. We forgot the crucial part of it. All right. I'm gonna need to get myself into the right mindset of doing this again. This is our culprit. We gave ourselves only one frame to do 4 inputs. Let's bump that up to 16. Now it should work. There we go. Look at him. It's only bumping him off the ground sometimes, but he's doing a little uppercut now. We can do a regular punch, but if you input a shoryuken. Now, why isn't he jumping up? Oh, well, we could actually just have it as part of the change to his sprite. There we go. Now it's not based off of his other Oh, it looks like he can't do it if he's against a wall, right? Wonder why that changes his movement like that. So there, he's got a little punch. He's got a little kick. He's got a shoryuken. And if I do a regular quarter circle forward, that doesn't work. I'll actually make a much prettier draw function for this sometime in the future. I'll copy that over from the other code I wrote, but for now we'll just have to deal with the little numbers on screen. So, there's an uppercut. Let's say if input is reversed and and h speed is less than 2 or 3 times, let's see. 2 is less than 3 times. I'm trying to think here. So what we're doing now is we should be able to have a quarter circle back input, which should rely on us not turning around immediately if we move backwards for a couple of frames. So let's think. If HSP so we'll need to check if our horizontal speed compared to our facing is a little bit lenient and a little bit within negative of what it is. Hold on, I'm trying to think about this. Because previously on my other code, I just used the state controller. Else if you move backwards and HSP is less than -2 times sine of facing, that might only work for facing right, right? So what if we did absolute value of HSP is, okay, hold on. If the absolute value of our HSP is less than 2, and HSP or and sine HSP does not equal sine of our, or does not equal facing. There we go. Okay, that should be it. If our absolute value, meaning, um, what absolute value means is if it's a negative, it becomes a positive. Absolute value basically means distance to zero. If we are moving less than 2 speed in either of our directions, and the sine of our horizontal speed does not equal our current facing amount, then we should be able to have a little delay in when we turn around, right? It's very subtle to see. Yeah, okay, so we don't even turn around if we just barely, barely tap. Let's go ahead and change that to 3. And now, if command input is down, then back down, then back with our kick button, we'll go ahead and say double jump speed. And where's our friction? If sprite index does not equal sprite character Tatsu, then we don't apply friction. But if it is, let's see, BSP plus equals 0.5, else if BSP is negative. So if we're currently moving upward, then increment it slightly forward. Where's our gravity? All right, VSP plus equals grav. If sprite index does not equal sprite character Tatsu, then we apply gravity. So there's other things we can get into with, for example, having physics variables, which lets us constrict this down to a much smaller space, or make this a lot less messy. But for now, oh, wrong button. I think we're doing it wrong. Yeah, we're still getting a forward input. So we might need to have a way to lock our characters facing. Oh, damn it, bumped the mic again. So this is very easy to handle in... Right, no, it's not back, it's reverse. Again, you have to know your own code that you're working with. Otherwise, you'll get caught by stupid mistakes like this. And once I get in the habit of messing with this regularly, we shouldn't have any issues whatsoever. So goes neutral, then down. There we go. Okay, it's very tight. But he's got a Tatsu. We can actually mess with the tightness of it. I think our friction is actually one part of what's going on with it. So, go back over to where we have our grounded friction. And this is where I'm getting lost in my own code. The Tims. Exactly. Welcome, Leviathan. I'm glad you're enjoying the time here. You like what I did? You like his style? Okay, so if command input is neutral, or we could change that to if he's not moving forward, then we apply friction. That might make it easier to do a tatsu. No, right now he's still, unless you're like Mixbox perfect, he's still turning around. So it looks smooth just because there's literally only 2 frames. And I can show you the sprites now that we've gone through all the spoilers. So there's just 2 frames in there that I literally did a bunch of MS Paint horizontal lines. You have that in there, and it gives it a bit of motion blur. And then you leave the fist out there for a few frames before bringing it back in. So now we just need to. How's that look so good? Because it's just a very, very small way to fool your eyes. Hmm. Let's think. Oh, wait. No, we want this to be greater than 3. Okay, so we had the less than or greater than incorrect. Now it should be much easier to do a tatsu, as he's going to take a while to actually, he's not going to turn around. Meaning we can input tatsus much easier. Ah, are we finally having issues with the vertical collision then? Let's see. What's it? Grid snap? No. Okay, there it is. Move snap 1 1. That keeps us constrained to 1 pixel on the screen. And that gave us a couple of issues with the vertical collisions here. Ah, okay. So now we want to spread this out into a little bit. So, if bracket this inside, if we're moving backwards a little, then turn around. Else, move you back over here. Else, we just move backwards a little bit. So make that a minus. And now we should be able to drift backwards slightly. And we'll have a few frames to be having some leniency for a tatsu. What did I get wrong? Oh, I missed a parenthesis here. And it was an extra one over there. Okay. Now we should be getting to the more compile errors. put in the missing bracket there, and now everything should be shipshape. Or we're just not turning around whatsoever. Okay, so we have to change our friction again. If it's neutral, if we have a neutral input, then apply friction. Otherwise, yeah, you can see he's still facing forward a little bit, even if he drifts backwards for a moment. So now it's really easy to input a Tatsu. But actually, you can have it face the other direction if you turn around right at the end. But I think that's an issue we can handle for next time. So there we have it. We have jumping around. We have a dash. The double jump isn't working right now. I wonder why. Oh, well, set that to 1. Okay, yeah, we have our jumps again. Set this back to 1, and our little boy should be perfectly playable now. We don't have any collisions or anything going on here. It's just animations being played. But walk around, jump, double jump, all this being handled through a controller. Double tap forward and you'll get a dash. Punch, kick. Shoryuken. Tatsu. So there you have it. 3-hour lesson. And while it was a little bit shaky in the middle, I might be able to get a properly curated one in the future. But there's a practical application to using strings and arrays. We have our inputs being fed into an array of strings. 2 arrays here. The one on the right shows us how long our input's been going. One on the left shows what our inputs are. Each of those gets bumped down every time they change, and our inputs are put in as a string, which we then read back over for whatever our inputs are. I like this. This is fun. Something made in just the span of a few hours. I think it's cute. Zoom in on our little boy. He needs a bit more visibility. Look at him go. Does he have infinite jumps from... Oh, yeah. He has infinite airtime if you Shoryuken quickly enough. Of course, we can adjust these balances here and there, but this is more of a demonstration of actually getting the inputs. He needs it. He needs infinite airtime Shoryuken, so once he gets a life lead, he can just stall at the top of the screen forever. If it's legal in Melee, it's legal everywhere. Well, I guess this is a bit of a platform fighter, since we do have it based off of a platform engine. All right. That's a comfortable 3 hours. So I do believe that formally concludes our lesson. I might do a tutorial on frame data in the future. I have no idea what we'd be doing next for a fighting or for a programming tutorial here. Those were basically a couple of the first lessons I wanted to do. I do have game dev aspirations in the future, and I might take a bit longer to settle on whatever our next lesson is supposed to be. So go ahead and discuss with me in the Discord or on Twitter. DM me on Twitter. And if there's anything you specifically want to see out of a future stream, say making hitboxes or dungeon generation fireballs like a Hadoken, let me know. I think I'll actually take the time to properly prepare a lesson next time, as we're still getting a feel of things here. We can go ahead and make a completed version that has all the code we need, and I'll have all the draw and debug functions in there and implemented. And then we'll do the same thing again. Work backwards off of code I already have completed. No stream scheduled for tomorrow, but I am feeling a lot easier on the voice since I took it a lot slower and I'm speaking not nearly as much tonight. So I might sneak in a stream tomorrow. It'd probably be Dead Cells, let's be honest, it'd be Dead Cells. Otherwise, no stream scheduled for tomorrow. Dead Cells or Guilty Gear if I do change my mind. Thursday and Friday will both be Guilty Gear, as well as Friday is going to be our next Strive tournament. Haven't had one of those in a while, so I hope to see you there. Thank you all for your attendance. This has been a wonderful lesson this evening. Class is dismissed. Ah, Jesse! Welcome. Fellow science. Fellow creature of science. We do have VODs always available on YouTube after the stream. We were going through with a programming lesson tonight, and if there was anything you did need to see from there, salutations indeed. I do have a YouTube channel that should be linked on 17. Let's go ahead and I need to implement an actual counter for that. So there should be on my Twitch page a link over to my YouTube channel, if that's correct. About, just double checking. Correct. Okay, I do have a YouTube link here, and you can get the entire VOD for this one and the prior lesson available there. And sometime in the future, I might make a more curated lesson for what we've done here today. But thank you for your last minute attendance, Jesse. I hope to see you in the future. But if you do want to look at what we did, I'll go ahead and dial down the stream with a little bit of. Hey, no. I'm supposed to be invisible. We had. Yeah, I'll go ahead and give you a rundown through. We actually made a fighting game input interpreter. Over on the left would be the button inputs that we're doing, and on the right is the duration of the buttons that we've done. We've done a little bit of movement around, jumping, double jumping. We have dash inputs if you need to get somewhere a little bit quicker. In fact, the dashes even work in midair. So this is an anime fighter. And then, of course, anything with fighting game inputs is going to need punches and kicks, and shoryukens, and a tatsu. So yeah, lesson's over. Did I? Oh yeah, if you input shoryuken a little bit slowly, he might turn around for it. And we do have a solution to get around this, which might actually require a bit of a change to our interpreter. That's all. I'm just gonna leave this open for a little bit and close out the stream shortly. See you soon, Jesse. Oh, wait. We need to raid. So let's fix that. Something that I do need to get in the habit of doing. While we're on the subject of science, oh, I guess it disrupted the tracking a bit. Sometimes I do need to look a lot more closely towards my camera. Oh, wait. I'm an idiot. Isn't it a slash? Or is it an exclamation point?